Okay. All right. Welcome everyone to the January community meetup. Happy New Year since we've last met. For the agenda, we have the community update, the product roadmap update, and we have Will, who's going to be introducing the primary keys and validation results. We're hiring. There's a couple of positions open. Check them out at jobs.greatexpectations.io. Feel free to reach out if you have any questions. Yeah, few spots open. Come join us. All right, gonna keep moving. Here's the project community stats. We're going straight towards 10,000. Super fun round number. Hopefully coming up soon. Yeah, we're at 9,284. Added on a couple over the holiday break. Usually it's a little bit slow for us, so 174, a little lower than usual, but people are having too much fun on the holidays. But I guess not too much fun because our PyPy downloads have really exploded. Or maybe you're having a blast with Great Expectations. That's more like it. Yeah, so our broke back over 300,000 on the daily, which is really cool to see. We had 1 million more than we did, or 1.5 million more than we did the month before, which is really exciting. Steady rise for usage of Great Expectations. Thanks to all of our GitHub contributors, everyone who's contributed to the project. I made a new slide with people on it. Hopefully people like that. So thanks to Neil, Hadas, Wagner, Tiago, JX2 Lee, Kim, another Tiago, Chris, Itai, Ankar, and Matush. Thank you very much for your contributions. This contributions have really exploded over the past couple months, which is really great to see. It's kind of it's what inspired me to make a new slide for this, and because now we have 2 slides worth of contributions, which normally it was 1 slide, maybe half the slide would be on there. So thanks so much for all the contributions, and thanks to Don and his team for really getting those PRs over the line within the community. All right, moving along. Thanks to our Slack supporters. Big thank you to these over this going from December to January. It's when we're really light on support from the team for DevRel. So thank you so much for the ones that have contributed over our holiday break when we weren't around. So thanks, Tiago. Really doing a lot for us in Slack, in GitHub. Thank you, Darsha, Lexi, Amori, Han, Veronica, Arvind, Philip, Dimitrios. Thank you so much for your contributions in Slack. All right, I'm going to pass it off to Don for the product roadmap.
Great. Yeah, thanks, Kyle. And we hit another milestone of 10,000 commits to develop. So that's, I mean, awesome. What a journey. And it just speaks to the level of activity that's going on within Great Expectations. So our roadmap continues to be guided by this statement that Great Expectations is powerful and expressive, and after years of development and 10,000 plus commits and widespread adoption by data practitioners, the core APIs are robust, stable, and thoroughly tested. Best of all, it's easy to get started. And so our focus is being able to make that statement like boldly and honestly, and we're investing in order to be able to make that increasingly true. We can go to the next slide. The way that is showing up in core themes for this year is around usability, community, and continuing to build and leverage the great relationship we have with the community, adding new capabilities to the product, and then making some specific investments in quality. And part of the roadmap that was shared last month included us hitting a 1.0 on Great Expectations later this year, and so those quality investments are going to be critical to that. Some recent work, we've got data docs including failed rows. So this is what will be presenting later in the meeting, so I won't speak too much to that, but it's pretty exciting and a long-standing requested feature from the community. And we've got some data context improvements with some state management improvements to follow. So right now, saving and loading different artifacts can be done in different ways with different parameters. and we're going to bring a great level of consistency there. If you've been looking very, very closely, you may have noticed that we've effectively retired data context and base data context within the code base in favor of file ephemeral and cloud data contexts. That for us on the engineering side has really reduced the complexity of having to maintain data context, which is getting to be quite a large object for us, while also providing specific areas where we can target functionality to particular environments. So like making sure that ephemeral is the best ephemeral data context, file is the best file data context, rather than having to have like data context that's kind of morphed in this way to suit this use case and then morphed in a different way to suit that other use case. It's been a huge improvement in code quality. Next. So I mentioned and Kyle highlighted the community PRs, and that this is really kind of a process change, but it's supported by how we think about prioritizing work and organizing the teams internally at Great Expectations. So our goal is to respond to any new community PR within 24 hours. We'll either, if it's great, we'll merge it right away. Otherwise, we may ask for follow-up, fixes, clarifications, those kinds of things. We'll allow 48 hours for that. We'll follow up again after 48 hours, and then we'll either decide as a team to adopt the PR and like own it and get it over the line and integrated, or we'll close the PR. I think the key reason for showing this is twofold. One is just to highlight the fact that we're really trying to maintain this kind of service level of responding within 24 hours. We think that's important just to acknowledge the effort and thoughtfulness that goes into contributing a new PR to Great Expectations and kind of honoring that effort on our side. The other is, if you have contributed a PR, let's say you worked on the weekend and then you didn't get back to it until the next weekend, you may come back to find your PR closed. That is, and we'll close it. We're trying to come up with a really friendly message when we close it to say like, hey, when you have time to come back to this, please reopen it. So I think the important thing here is if you do find your PR is closed, don't take it as like a criticism or anything. Just it's part of this process that we're trying to adopt to stay on top of the number of open community PRs, and please do reopen it when you have the opportunity to return to it. Next. So other recent work, we've got new API docs. You've got a little teaser of it on our website today. If you look closely under reference and abstract data context, which is anchoring some of that new data context work I mentioned before, it should, well, it looks like the API doc that you know and love from your other favorite Python libraries. Because we're using Sphinx, which is a very common document generating tool for those libraries, and then we've integrated it with Docusaurus, which was definitely a big square peg round hole problem, but we've surmounted it. And we are actually having everybody in the company write doc strings at the end of this week. So you should see the API docs that we have in our main docs site really explode. And this will be allowing us to then retire our V2 site and just create fantastic documentation for the product, which we think is so critical, given that we're a developer product, and developer products all have great API docs. So lots happening there over the next short period. We can go to the next, Kyle. So Expectation Gallery. The Expectation Gallery is a tool on our website. Here's how, if you go under resources and Expectation Gallery, you click that, go to the next slide, you'll see the site. And here we've really cleaned up the docs for all of the core expectations and the tests that certify that those expectations work against particular backends. So the core expectations, the ones that are produced by the GX team, now I think more than ever represent a great example for others to follow when they're looking to contribute their own custom expectations, because of the level of completeness and documentation that we have around it. We've got further like styling and navigation improvements in the pipeline for the gallery, but there's been a ton of good work just shoring up the tests and the documentation for core expectations. Wanted to highlight that. Next. Integration guides. So when we shipped the golden path for GCP, the first ask was like, can we get it for AWS? and it is arriving. So we've got the first one here around S3 and pandas, with more to follow. Rachel's done some fantastic work to like pull everything together and aggregate the bits that we kind of had scattered all over the site into a comprehensive guide that you can follow end to end, that should answer a lot of your questions around getting this particular integration set up. So we've got ones coming. Well, and Rachel, you can speak to this. We've got Spark, and you were enumerating them all to me this morning.
Spark, Athena, and Redshift. Spark and Athena should be coming up next, and Redshift shortly after that.
So that's going to be great. Next slide. Oh, and we also snuck in support for Python 3.10. So we now have our full CI environment running against Python 3.10. We had to update a couple of tests to get it to work. But if you're using Python 3.10, you can now use it with great expectations with confidence. Cool. All right, one more slide for me. I am super happy to announce Susie as a senior product manager for Great Expectations. So, which is this product, the product we build that's part of open source. So Susie, I'll turn over to you.
Thanks, Don. Hi, everyone. Very excited to join. I think there's a lot we are planning for 2023, so it's a perfect time for me to join. My background's in data science and product management. I mostly worked for analytics companies, so I definitely know how important data quality is. Originally I'm from Hungary, and now I live in Miami. And maybe one fun fact about me is that I went to college in Amsterdam, where Python was invented on my campus. So I remember I got exposure to a lot of Python libraries in college. We actually weren't allowed to use any other programming language. So yeah, that's my background. Very excited to dive into all the community requests, learn more about all your use cases, pain points. Also I eventually, hopefully, will actively contribute at one point. I have some custom expectations in mind. Feel free to reach out, and nice to meet all of you.
Thanks, Susie. And thanks, Don. Yeah, so happy to have you on board. It's definitely a big missing piece. It'll be good to help us really get that feedback from the community into the product. So yeah, looking forward to seeing that in the works. All right.
Yeah, super excited.
Cool. All right. Thanks again. We'll keep going to our feature presentation for primary keys and validation results by Will. So Will, take it away.
This one, so because there's a demo link to it, so I think it'll make the transition a little bit easier. So if you allow me to hijack. Here we go. I think everybody can see my screen okay?
Yep, you are good to go.
Great. So the title of my demo here is Primary Keys and Validation Results. And I wanted to start us off with a little bit of a history lesson on where this feature came from. The feature came from originally an issue submitted by the community some time ago, and it had to do with a limitation of expectation validation results. So if you've used GE for any length of time, you know that these EVRs, or expectation validation results, show you a partial unexpected list, which is where or what the unexpected values are, and unexpected value count, which is how many there are. And so one piece that was missing was, where are these unexpected values? And so this sort of limitation made identifying kind of where the bad data was, diverting it, maybe splitting your data up into the good and bad portions, a little bit more difficult. And it was a discussion kind of started off by Ken Parton here. A lot of other community members were able to contribute to this discussion. One user, Aiden Fennessy, got the ball rolling in terms of the pandas implementation. And it was a great example of something that really was motivated by the community. Kind of the baton was passed on to the core team, And GE, as a company, we were able to sort of take this over the line. And so thank you all who joined in that discussion. None of this functionality that I'm about to sort of demo today would have been possible without every one of you. And so on one asterisk is Pandas had this unexpected index list that was a list of indices according to the default Pandas index, but it was kind of a limited output, and it certainly didn't work for SQL or Spark. And so this feature kind of expands that functionality to the other backends and execution engines. So to sort of illustrate where or how this works, I wanted to kind of use an example. So this is a SQLite table called event names. And in our example, this table is storing page view data. And so we have event ID, visit ID, date, event type as the columns. And anything related to page view, so page load and page view, are expected. And things like user sign up, purchase, or download are not. And so if you had this table coming in on a regular basis and you wanted to detect when non-page view data was getting included in the table, you might set up an expectation like this. So here is an expectation configuration where expect column values to be in set is our type. Our quargs include our column, which is event type, and we give it a value set. So page load and page view. So it'll kind of use these values as the expected values. And if you add it to a checkpoint and you run the checkpoint, then you would get, as we described before, this unexpected list. So user sign up, purchase, and download, which is our unexpected values, as well as their counts. But markedly, no way to sort of identify where these values were. And so this is where this primary key functionality comes in. This kind of new way of interacting with the data allows primary keys to be specified using the unexpected index column names parameter. And it's defined at the result format level for checkpoints. And so it looks something like this. So this is a result format dictionary. If you're familiar with this functionality, you'll know that it can be like a just a key value, or it can be layered. So it can be result format, new dictionary, result format complete, and it allows you to specify more than one thing. And this is where this parameter goes in. And so in this example, unexpected index column names is passed into the result format dictionary, and we've identified event ID as our primary key column. And then what we can do with that dictionary is we can either run it as, or we can pass it in as a parameter to the run checkpoint. So this is the same checkpoint as before, but now we're giving it this run format dictionary. Or we can actually add this to the runtime configuration of the checkpoint configuration itself. So that YAML can also take in this parameter. And once you do that, then that same EVR, or the expectation validation result, will include a unexpected index list. So this is the same parameter that Pandas used to have, but now we've sort of expanded this to the other backends. And this comes out as a list of dictionaries of the unexpected value itself, as well as the primary key that we define. And so here is an example. So remember, if these were the unexpected values, right? The non-page load and page view rows are the ones that we want. And the result now includes event type, which is our column here, user sign up, event ID 3, which tells you where it is, event type purchase, event ID 4, event type download, event ID 5. And so if you have multiple values that are identical, then this will include all those locations. So kind of taking this list of dictionaries will help you pinpoint exactly where those kind of bad rows are. The output also includes something called the unexpected index query. And the intent of this parameter, or this result, is to allow users to retrieve all the unexpected results from a table or a data frame. And so this is it also comes with a parameter where you can suppress it. So return unexpected index query. If you set it to false, as we see here, you can suppress this output. And the default is true, so you'll get this unexpected index query by default. And this is a little bit different for each backend. So SQL output for that, for our example, will be the query. So selecting event type and event ID from event names, which is the table, And here's our condition where event type is not null and the values are not in page load and page view. This is internally the query that is run against the database backend, but running this query, like copying this into your database interface and running it will allow you to retrieve your original, the unexpected rows from your original table. For Spark, it's a very similar thing, but it's a condition on the data frame. And then for Pandas, it's a list of all unexpected indices and unexpected indices. And one kind of thing that I'll be showing in my demo a little bit too was that unexpected index query can include multiple indices. So here's an example where both event ID and visit ID are specified. And then it can also include for Pandas the named index column. So it's the one where you get one by default, and there's a way you can kind of name a column as an index. And this functionality will allow you to interact with these named indices as well. So what do they look like rendered? Here is a kind of a screenshot of a data doc. We'll be interacting with one later. But where this information has been added is the existing unexpected count table. And so here, everything up until this column was something that already existed. But on top of that now is our event ID primary key column along with the values. And just as a side point, if you have situations where you have like a lot of unexpected values, it'll display by default up to 10 values and it'll do ... So you're not overwhelmed with like hundreds of these unexpected indices in your data docs. And then if you look down here, there is a to retrieve all unexpected values, and it's a drop-down menu. So if you click it, then the query that we talked about before, that'll come up, and you'll be able to kind of copy and paste this to wherever you're interacting with your table. So now is a demo kind of illustrating what we just talked about. And so here is just kind of a setup. So here is a batch request for retrieving the events names table. This is a SQL example. And if it's useful, I think this is a set of examples like for Pandas, Spark, and SQL, where it can be uploaded so that users can kind of play around with this working example of IDPK. But just for the sake of demonstration, please know that like there is a Great Expectations YAML file connected to a SQLite database, identical to the one we were talking about in the presentation. And here is the checkpoint configuration. So let's first load GE. We will be getting our context. And then batch request. And now we've added our checkpoint to the configuration. So it's really simple. We just have the batch request as the validation. We're storing them. We're storing evaluation parameters. And critically, we're updating our data docs. And so for our first example, unexpected index names are not configured. And here is something that's probably familiar with everybody, but we've taken our EVRs and we're showing just the result. And we don't really see, so we have the partial unexpected list and the counts. But now, in our second example, we've defined unexpected index column names. And so that same checkpoint output will include our unexpected index list. So here we have purchase as the event type value, event ID equals 4, event type download, event ID 5. And we also have our unexpected query, which is what we showed before. And then just as a final example, wanted to show the specifying multiple index column names. And it's basically the same output, but you'll see that the dictionary contains one more key value entry. And the index query selects one more column. And so that way you're able to get the rows that are wrong and just the columns that you are interested in. Now let's, as a final sort of demo, I'll show how these show up in our data docs. This was the original one without any unexpected index column name specified. Here is our example with one column specified with our query. And then here is what it looks like with 2 columns. So event ID, visitor ID, and then the query is updated to include all the 3 columns that we are now interested in. So that concludes the demo. I just wanted to thank again, I mean, everybody who helped with the discussions here. This really was a kind of a collaboration between the core team and the community. And so really getting this far and having this hopefully very useful functionality would not have been possible without the community. So thank you all who contributed, and thank you all who will be using this in the days to come.
Thanks, Will. That was awesome. And you got through the live presentation. Congratulations.
I did without exploding.
All right. Does anyone have any questions right now that Will could answer, or stuff that Don was presenting on earlier? If not, always, you know, I'm sure this is a new thing that Will's presenting. Feel free to play around with it and ask questions in the Slack community. We'll be there. All right, cool. Well, thanks everyone again for coming. We'll see you next month. If you're interested in ever doing a presentation on your use case or things about data quality, let me know. We'll make some room for you. All right. See y'all next month.
Thanks, everybody.
Thanks.
Thank you very much.